Hello, and welcome to another episode of Notes with Mrs. Flint on her back porch at the end of a day. So, today in class we talked about the mole. And we talked about the mole being a unit of measurement that was equal to 6.022 times 10 to the 23rd things. So we could have a mole of dogs, since my dog is sitting next to me. We could have a mole of mules, since I can see him standing in his pasture. We could have a mole of students, a mole of chairs, a mole of hummingbird feeders, which needs to be filled. I'll have to do that later. But we're in chemistry class, so our things that we're going to be counting are things like compounds. Compounds are going to be a group of atoms that are joined together. Or we could be counting atoms in chemistry. And these would be elements. Or we could be counting ions, which are charged particles. These are the types of things that we would count in chemistry. Now, a mole is a very, very big number because the things that we're counting are very, very, very small. And so, when we're looking at a balanced equation, these are chemical equations. You've seen these before. When you did biology class, you saw a chemical equation that was carbon dioxide plus water will create inside the chloroplast glucose or sugar, and it'll release oxygen. That was a chemical equation that you should be a little bit familiar with. Here's another example of a chemical equation, and this deals with a mole ratio. The numbers that are in front of our chemical symbols stand for how many moles of that substance you need. So in this example, you need 2 moles of hydrogen, 1 mole of oxygen, and that will yield, the arrow disappeared there, 2 moles of water. So the numbers before the symbol for the substance tell you how many moles of that substance you need. All right, before we did this lesson, we were talking about and practicing converting. We used the factor label method or dimensional analysis method to convert from one thing to another. We went from, let's say, teaspoons to gallons, or grams to pounds. We did miles to inches, and we did minutes to years. When we're going to be using the concept of the mole, we're also going to be using conversion factors. So I'm going to kind of divide these into 2 parts because you need to treat these in a little bit different way. One thing is compounds. Another thing that you'll be asked to convert is elements. And these are very similar, but we kind of have to handle them in slightly different ways. So let's say that you're starting with grams. You've got a chemistry question that says you have this many grams of a compound, let's say water, and we want to know how many particles that'll be. Well, there are steps in conversion factors you're going to need to go through. We're going to need to convert the grams to a certain number of moles. And then for moles, we're going to need to convert those to our number of particles. In this case, this will be molecules. Now on the other side, we have elements. And let's say again, we're starting with grams. We have a certain number of grams of an element. We're going to need to figure out how many moles of that element are present in that weight. And then finally, we want to find out how many atoms. So we're going to need another conversion factor to go there. So let's jump back to the conversion factors we're going to need. For grams to moles, we're going to have to calculate something called the molar mass of the compound. That's a conversion factor that we're going to need. Now, once we have that, we can figure out how many moles are going to be present in that amount of, or that weight of the substance. Going from moles to particles, we're going to need to use Avogadro's number, which is 6.02 times 10 to the 23rd. So using that conversion factor, we're going to be able to get to particles. Now, don't worry, we're going to demonstrate this and you'll have lots of practice, but this is the map of how you're going to get there. Let's look at the elements side. For the elements, it's a little bit simpler. All you have to do is use the periodic table to find the molar mass for that element. So you're going to need to just look it up on the periodic table to find the mass. To go from moles to atoms, again, you're just going to need to multiply by 6.02 times 10 to the 23rd. So in these problems, you're going to need to use two different conversion factors. So let's talk about how do you calculate the molar mass. The mass on the periodic table is measured, if you measure it out in grams, is equal to 1 mole of atoms of that element. So you can also call it the molar mass. For example, when you look on the periodic table, a mole of sodium, a mole. So 22.99 grams. Very important to put grams. If I just leave that 22.99, I don't know if I'm talking about a mole of the substance or if I'm just talking about a single atom. Now, there are different types of compounds. One is called a molecular compound, and the other one is called a ionic compound. We'll get into a lot more detail about those, but it doesn't matter whether it's molecular or ionic. You're still going to calculate the formula mass the same way. Now, the font on my notes that I'm showing you here is a little different. Your note sheet is better. This should have been written as CaNO3 with the 3 drop down, 2. Now, another way to write this, and what this formula is telling us, is that we have a calcium atom, and we have 2 units of this NO3. There's one, and there's one. I'm going to back that up so I can make it a little neater. So this 2 is telling us I have 2 of the NO3. So when I'm totaling up the elements in this formula, I can write them out. I've got calcium right here. I've got nitrogen right here and right here. And I have oxygen. I've got 3 of them here and 3 of them here. So now what I'm going to do is I'm going to say how many of each type of atom. Well, calcium, I had 1. Nitrogen, I have 2. 1, 2. 1, 2, because it's 2 times everything inside the parentheses. For oxygen, I have 2 times 3, or 3 plus 3, giving me 6. Now I have to use my periodic table to look up the weights of each element. Now I have to look up nitrogen. And now oxygen, 0.00. And I do want to keep all the zeros because remember when we're adding significant figures, we have to keep the same number of decimal places. So now I'm going to use my calculator and figure out 1 times 40 is 40.08. 2 times 14.01 is 28.02. 0.02, and 6 times 16 is 96.00. Now the last thing I have to do, because we want the total weight for this compound, is I'm going to add these numbers together. And when I add these numbers all together, I'm going to get 164.10. Again, I need to keep that 0 because that tells me the number of significant figures I have. Now, I have to use the unit grams, and that will be the molar mass for the compound that I've just calculated. So now I'm going to go ahead and do the next one. And I got dogs barking in the background, but that's all right because I'm home on my back porch. So I'm going to look at which element. Now this seems to be a really complicated formula. I'm going to rewrite it so that you can see it the way it should be written. CH3 with the 3 drop down. CO, CO, CH3. So now the same thing, I'm just going to add up how many of each element I've got. Well, I've got carbon atoms, I've got hydrogen atoms, and I have oxygen atoms. So my total amount of carbon atoms is going to be 4. My total amount of hydrogen atoms, I've got 3 here and 3 here, so that's going to be 6. Total amount of oxygen, I've got 1 here and 1 here, so that's going to be 2. Now I'm going to look up the masses. So carbon, if you look on your hydrogen, and oxygen, we already did oxygen, it's right up above there, it's 16.00. So now I'm going to multiply and find out how much I have of each element. 4 times 12.01 is 48.04. 6 times 1.01 is 6.06. And 2 times 16 is 32. And now I'm ready for my total. Put those in the calculator. 48.04 plus 6.06 plus 32.00 equals 86.1, and I gotta have that 0, so I have the right number of significant figure, grams. And there we have it. Now, I'm going to keep going and actually do the homework problems. So if you watch this right up to the very end, you'll actually be able to check your homework. Here's our periodic table. And we're going to zoom in on sodium. We can look at our diagram here, and it tells us that this is the atomic mass, that lower number. So when I focus in on sodium, I see that the weight of sodium is 22.99. Now, the weight of one sodium atom is 22.99 AMU. If I just put the unit grams on there, that's the weight of a mole of the substance. So 22.99 would be the weight. So the first one I'm going to look for is calcium. There's calcium, 40.8. There's nitrogen, 14.01. It's right there at 16. The table is right here, 12.01. It's way over here to this side, 1.01. Here we go. Periodic table. Make this little so I can see it easily. Chlorine is right here. 35.5 is right here, and it's 39.10. Beryllium, there it is. It's a little one, 9.01. Right there, 24.30. Zip back to number 5. There's our homework. So remember the problems that you were assigned are 1 through 7. So the first one is Cl2. So that's going to be chlorine. Let me get a purple here. I have 2 of them. So that's all there is just chlorine. So I'm ready to put it in the calculator. 2, because I have 2 atoms of chlorine. So 2 times 35.45 equals 70.90 grams. I'm just going to abbreviate grams. Now we have KOH. I've got 3 different elements. I've got potassium, oxygen, and hydrogen. I've got 1 of each of them. So potassium, oxygen is 16.00, and hydrogen is 1.01. I'm going to add all these together because it's times 1. 39.10 plus 16.00 plus 1.01 equals 56.11 grams. On to the next one. I've got beryllium and I have chlorine. For beryllium, I have 1 atom. I'm just going to draw a little line to kind of separate this because they're getting kind of close. For chlorine, I've got 2 of them. Now I'm ready to go find chlorine. I already know because I had that above. 35.45. But I have to look up beryllium. Now I'm ready to get the totals. That's going to be 1 times 9.01 is 9.01. 2 times 35.45 is 70.90. Going to add these together. 70.90 plus 9.01 equals 16.10 grams. And there's that one. All right, now I'm going to pause this and I'm just going to go ahead and work these out and put the answers down, and then I'll pop the answers at the end. I think maybe I'll do number 7 since it's a little different with the parentheses. All right, I'll zoom back out so you can see the answers in just a second, but I wanted to zoom in on number 7 just to kind of work that through with you. So the first thing I'm going to do is list the elements. So I've got magnesium, I've got oxygen, and I have hydrogen. I have 1 magnesium. Now, because the 2 is outside the parentheses, it means everything inside is multiplied by 2. So I've got 2 oxygen and 2 hydrogen. So magnesium, oxygen is 16.00, and hydrogen is 1.01, which means I'm going to have 24.30. For oxygen, I'm going to have 32.00. And for hydrogen, I'm going to have 2.02. Add them all together, and what do you get? You get a whopping 58.32 grams as the molar mass. There you go. Let me zoom out so you can see the rest of the answers. So for number 3, there's my answer. For number 4, there's my answer. Number 5, number 6, and number 7. There you go. I hope you found this was helpful. The end. Section. Whoop.